So what we have mentioned, for example, the assistive technologies, we don't want a joystick. Okay, we don't want a joystick to control the wheelchair. We don't want a button to control the machine. So we want something that is more natural and then is directly related to our brain. Is directly we can get the information from our brain. So yeah, another hot topic. So robotic is from Elon Musk, and then this topic is also from Elon Musk. He is one of the star. So BCI, brain computer interface. So how the wearable device can be affected by our brain or a new system, we can extract, get the information from our new system is one of the interesting topic in the wearable device. So in the BCI, in the brain computer interface. So honestly, you can think about Elon Musk, right? Neuralink. So they are designed for some assistive technologies. They are designed for someone who backbone is hurt, and then they cannot move, they cannot control the I would say that all the muscle, all the function from their lower body. So they want something that can extract the brain signal, and then help them to do the walking, standing, even to only grab the object from the environment. So that is one of the things we want to do because we want something that is not only understand the scenes, understand the current environment by the camera. We want something that is exactly from our brain, exactly from our brainwave that we can control all the mechanical device. And yeah, that is really important. So you have to understand the some keywords. Brain computer interface is one of them. So it's a overall big picture of the this kind of wearable device. But if you go deep, so there is a special catalog called RNS, responsive neural simulations. Here, responsive neural simulations. So that means when you are under the MRI, okay, when you're under some scanning, so they scan the signal of your wave, they receive the information from your wave. So they keep on give you some simulation. For example, hey, I see some object pass through, right? So my eye spot will focus on this object, etc., etc. Or somehow when you feel happy, feel unhappy, when you want to control your hands to grab something. So this one is we generate the simulations and then we record the response from your brain. So this is called responsive neural simulation system. So, so they try to receive and recognize the unique brain patterns. So as I have mentioned in our neural network, right? So we have a brain cell that store the meal bottle. We have another brain cell store the hungry. So when they are simulate with each other, so there is a say that the neural network. So the weighting of the linear equation increase, and then if you will go to new setting, so the chemical between these two brain cells will be increased. But the milk bottle in the brain cell A and then the hungry in the brain cell B, they are random. So somehow we know that some of the information will go to a certain area. For example, this part is for visions, and then this part is for your audios, and then if you MCI, so somehow I'll say that this part will be heard. So somehow we know that a certain area, but we do not know the exact brain cell A, brain cell B, brain cell C that store your milk bottle or hungry. So we need someone to have the unique or personalized simulations and then response system to identify these kind of things. And this is personalized neural modulation therapy or responsive neural simulations. One of the, I would say that not so extreme BCI, brain computer interface is extreme that so some of the wire they go directly into your brain. But you say that we are not doing so extreme, so somehow we have something called ET. So they just put the sensor on your head only, not directly go to your brain, and then scan the brain signal. So they have different channels. So the cheapest one will be 2 channels. That means they try to identify your alpha channel and then to see whether you are focused or not. And then of course by increasing the number of channel and then the accuracy or I would say that the level that you can trust will be increased and increased and increased. But try to think about if it's 128 channel, 128 channel, so it costs around 1 million Hong Kong dollars. And this kind of setting will be stored inside a laboratory. So it's inside a special room, and then put this kind of setting inside. So it's not portable, and then it's not so I would say that ready to use in your daily life, and that is EEG. So a better way to understand the EEG or understand the RNR system. So somehow it's here, your brain, and then the sensor is installed or put, not installed, okay, not installed, put on your head only, not direct go to your brain, and then absorb the, I would say that observe the signal of your brain wave. So that's the setting. So most likely they put on the different parts of your brain, and the cheapest one, two channel, and then its bottom one is here, observe your alpha channel. So when you receive the simulations, so somehow, for example, you want to focus or you want to control something, that your brain wave will be actively doing something, and then they will try to monitor. It goes to a signaling monitoring process. So here is the signal of the EEG, and then you want to or you need to identify a certain patterns of your brain wave, and then understand when I'm, for example, I'm seeing reading the PowerPoint, so I'm focused on the PowerPoint. So my focus channel of our visions and then the alpha channel will be increased. So they try to identify this kind of the brainwave patterns, Or when I say easily, when I say a foul word like F word, so I'm very angry, and then we want to absorb the signal of the angry. So it also try to increase a certain part of the brainwave in somewhere in our brain, and then we do the monitoring, do the detection, and put the simulation. For example, make them angry, make them focus, make them doing a repeat part, and then we observe this kind of patterns. And then by observe these kind of patterns, we know that hey, when this kind of pattern can be observed again, you will be angry, you will be focused, or you are doing a certain kind of actions. So that is the situation. Yeah, and then the wearable device also helps you to reduce the muscle pain by generate the infrared or by generate some pulse, electricity pulse, and then to reduce your muscle pain. So more or less similar to when you go outside to do the massage or to do the facial, right? So you try to use some physical stimulation to relax, to make you relax, and then to reduce your pain.
Chronic pain can be incredibly debilitating, so Quell is a solution that uses your own body to provide natural pain relief. My name is Lexi Savides for CNET here at CES 2015. Quell is a solution that uses electrical stimulation in order to get your body to reduce pain without the need for medication. You attach Quell to your upper calf, and from here it provides an electrical stimulation in order to provide the pain relief, regardless of where that pain is. The Quell is designed to be discreet and can be worn underneath clothing and throughout the day and night. There's also Bluetooth connectivity, so you can keep an eye on things like your sleep progress and the amount of pain relief and treatment that you're getting through an app. Now, the Quell is FDA approved, and when you order the system, you get not only the device, you also get the attachment to put it on your calf and the electrode device in order to place it on your calf itself. You simply peel off the sticker and attach it to your skin. The Quell is going to be available for around $250 when it ships later on this year. The Quell is a consumer version of a product that's previously only been available to those who have a prescription. So if you're looking for a solution for chronic pain, the Quell may be it. My name is Lexi Savides for CNET here at CES 2015, looking at the Quell wearable pain relief system.
And of course, Apple Watch, right, or all the daily wearable device, they try to monitor your health by monitor your heart rate, by monitor your physical exercise, physical activity. So they note your health, and then they note your health conditions. So the wearable device such as Apple Watch, Fitbit, Garmin, or Polar. So they try to understand your biometric marker, the physiological parameter, and then change of condition of your chronic disease. So they monitor your heart rate, they monitor your heart pressure, and also maybe the blood glucose. That means the blood sugar level. Yes, there are some of them. For example, liver life. So they also monitor the blood sugar. So it's quite good because for the diabetic people, so you know your glucose levels, and then you can, for example, you can insert the insulin or do all the things that can help you to reduce the blood sugar, to reduce the glucose level. So you offer a better way for your health management. You offer a better way for the medical decision making. So it's quite a good wearable device, and then it's quite a, I would say that, trustable settings for our health monitoring. So what are the things inside a smartwatch? So what are the components inside the wearable sensor? So 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 major components. The most important thing, of course, is the sensor. So there are some common sensors that you can also find in your smartphone. For example, accelerometer and gyroscope that we have discussed inside our VR AR settings. Of course, you will not take your mobile phone and then do the exercise with your mobile phone. You will use your smartphone, or you will use your wearable device, and somehow when you are doing the exercise, and then you will still capture or record this kind of activity by your wearable device. So this is better because they are nice, and then they are exactly monitor the things that you are doing. Because when you are swimming or when you are doing some very extreme exercise, so most likely you will not use your mobile phone, and then you don't want to wear additional sensor. So that one is really important. So yeah, accelerometer and then gyroscope for your activities, and then heart rate monitor. So somehow you will combine with the light sensor, maybe as light sensor. So they know that your heart rate. So they generate some blue rates here. Do we have? Yeah, they generate some light rate, and then go through your skin, and then after they go through your skin, so they know that how many blood is passing through under your skin. So they use this kind of technologies and then detect your heart rate, and then also detect your blood pressure, etc., etc. So right now the heart rate detection is pretty good. So by observing the heart rate, we know that you are doing the exercise, or we know that you are depressions, or you are excited, focused, etc. So we try to match into some from the signaling to some human activity. Then sometimes they also have the temperature sensor, so to observe whether you are fever or not. So this one is quite important, because if we can observe your fever, so it provides lots of the information about your disease, or about whether you should see a doctor or not. Some of them, they also have the GPS. GPS connect with the connectivity, and then know where you go, and then understand whether you are using a machine to do the physical exercise. How to say that? Some today, I don't know why, but some of the user, they want to cheat the sensor, so they buy some I would say the physical machine to swing their smartwatch, to make the cheat to make the fake data. So that's interesting, but yeah, I don't know. So GPS is better, so it do not allow you to do so. With different kinds of the sensor, so we combine all the things together, and then you know your health condition, and then it also can be used to do some, I would say that, multimodal machine learning algorithm to match into some activity that you want to measure. Second, display. Of course, they have some basic display. Mostly today they are using the OLED, so or e-ink. So there are two different display, or I would say that this one is just like a paper, and then this one is just like an electronic device, and then they emit light. One is reflect the light. E-ink is reflect the light. and then OLED is generate the light. So they are using different two settings to provide the display. So basically provide the displays for you, and then basically they provide I would say that, yeah, because they provide the display, and then they will also provide some of the phone call and additional information to you. So it makes you feel more confidence, or sorry, more convenience to use this kind of settings. Connectivity is interesting and important. So most likely today the device will be connected into smartphone. But how often, what is the frequency that you should connect with the smartphone will be asked. Because just like my ring, right? So my ring, usually they just connect once a day, or I don't know, 2 days, and then they just collect my data once. Because if they always connect your data from your wearable device, it causes another problem. It's the battery. So the battery will be used up so fast. So they are contracted with each other, connectivity and battery. So yeah, that's the situation. And then connectivity. So you can use the Bluetooth, Wi-Fi, NFC, and today even the Apple Watch. So they have the 5G SIM card into it. So they are always connect. But because of the always connect, and then they spend lots of the battery. Processing and storage. So as I have mentioned, they have a small CPU because they don't want to send all the connectivity. They don't want to send all the data. So they have the edge computing to process a little bit internally by using the wearable device, and then send the critical data or most important data to the user or to the smartphone. So that's that things. Yeah, because you have the CPU, and then you have some internal memory and then storage system to handle. Wearable device, of course, you can find something, you need to connect with your body, right? So you cannot just use a sticker. Yeah, sticker is not, it's too sticky, right? It's not usually we will not use that. So a rubber band or some metal. Yeah, metal, most likely use the metal. Metal is here. Metal is here. Or some bands that can hold on your body. So that is interesting. And then it goes to material science. It goes to fashion and tester. Operation system and software. So today all the wearable device, they have a special OS. So they operate the basic AI algorithm or machine learning algorithm, just that I've mentioned. They use the edge computing, right? So they have the special operation system and software to do it. Maybe they have some additional feature. Maybe so they have the communicate with each other. So they have the music payback, they have the voice payback, they have the contactless payment. Your Apple Pay or your Google Pay is something like that. So they try to combine with different usage on your wearable device. So yeah, three step, right? Step one, sensor. Step two, how to process the signal processing about the wearable device. So let's try to discuss a little bit more about this part. So not only about the wearable device, usually for all the signal processing. So it goes to 1, 4, 4 main category. The first one is data kinetic. So that means that when some signaling comes, so usually they will be affected by some extremely or warm product. So the first one is kinetic. So try to remove some, I would say that extreme data, or I would say that some data you can easily find they are warned, right? They are not the correct data you want to collect. For example, say that about the heartbeat. So the heartbeat, usually you have the light sensor and then detect the heartbeat. And then if some of the signal they cannot get it, that means they zero, zero, zero. So this kind of data you can remove because it's unreasonable. So usually we can get a certain amount of impulse, and according to delta time, so you will change a little bit, a little bit, a little bit. But if you say that it's a long time zero, then this kind of the path, this kind of the image can be removed. So it's not correct. Or it always go to an extremely high rate. For example, it can be always one. That means that all the signaling is zero, or all the signaling they are one. So all this kind of signal you can, these two extreme signal you can remove. First one, data kinetic. Second part, data normalization. So normalization, that means I want to normalize all the data into a certain time. So after we remove the extreme, then I want to normalize the data into, most likely it should be 0 to 1, 0 to 1, because if it's normalized to 0 to 1, it will be easy to compare with each other. For example, the heartbeat and also the blood pressure and also the other things. So if some of them, they go from 80 something to 130 something or 200, 80 something to 200. Some of them, for example, is about the pressure is 130 go to 190 something, right? So it's hard to compare. So if you want to have the multi-model, multi-information combined together and then do the prediction or do the machine learning, so you have to normalize all the dimension of the data into a certain amount so that we can compare, we can understand the similarity, and most likely is 0 to 1, 0 to 1. So that is called data normalization. Data normalization. Third one, dimensionality reduction. That means we reduce the useless data. So this part most likely is goes to the I would say that laboratory setting. If it's already production, so usually we use all the dimension. What's the meaning of dimension reduction? For example, I want to detect the brain wave. Okay, I want to detect brain wave, and then they are starting from 128 or above, and lots of the channel may be useless in your in your daily activity. For example, if you just want to detect whether they focus or not, so only two channel is important. So alpha channel, so 126 channel may be useless, but in your research setting, so most likely you still need to collect all of them, and then you use the PCA or you use different kind of algorithm to filter out, to remove this kind of useless channel, useless dimension. This is called dimension reduction. Because yeah, if you put lots of the thing to do the I would say the machine learning, and then you spend lots of the computation power, it costs a lot. So usually we in the laboratory level, we do the reduction, dimension reduction. And then when we go to production and development, we will use all the channel because they are already filtered out. They are already filtered out. All the channel that go to the production is the most important thing or most meaningful dimension, and that is the things we will do. The fourth part will be data segmentation. Is related to the time. So some of the I would say that signal patterns, they may be like this one. Some of the signal pattern may be like this one. It's longer, right? So we need to find a possible way to chop, okay, chop them into different segmentation, chop them into different segments, so that we can say that, hey, this part is related to the heart disease, and then this is the irregular heartbeats pattern. So we have to understand. So we need to chop into different patterns. Again, this part is go to machine learning. So yeah, you need not to go deep into the algorithm, but at least you have to understand 1, 2, 3, 4. So there are 4 parts: data cleansing, data normalization, dimensionality reductions, and data segmentation. 1, 2, 3, 4. So we go deep about these 4 categories one by one. So we will introduce some of the algorithm, but we will not go deep into the mathematical calculations, and then do the I would say that do the calculation one by one. The first one we want to do is handle is data cleansing. So that we have mentioned. First one, handling the missing value. So there are lots of the missing value. For example, go to 0 and then go to 1, etc., etc. So 2 ways to handle the missing value, or I would say that the easier ways to do it is remove, delete all the missing data, because it's hard to get it's really hard to estimate the situation, because when you do not have the correct data, maybe it's a 0 or maybe it's always 1. So that means there may be a problem in your sensor. You have to repair. You are not going to just find a estimate value to replace all the things. But if you say that we want to say that find out the missing data, you're not going to remove the missing data. So still there is some way, statistical way, is find the mean, mediums, or mode. For example, you have the in certain time A and certain time B, all the data here is missing. Then we just take the average of the A and B, or we have the A, B, C, D. So inside the A, between the A, B, C, they are missing, and then we use the A, B, C, the mean and the average as a one of the sample to fill out all the things. And of course, you can also using some mathematical way. For example, you use the ABCD plot a linear equation, and then you use this linear equation to handle the missing value. Is also possible because inside the say that signal processing is all related to time series. So if you only have the missing data at a certain time, we can use the previous time and then the t plus, I don't know, p plus n or t plus n plus 1, etc. And then you can use the time to estimate the data in between. Second, about the data cleansing that I have mentioned is remove the outlier. So you can use the box plot or the zero score. So we only handle the most frequency value in the middle part. So for the outlier, for the box plot outlier, we just remove it. Again, the most easier way is to remove all the missing data and the outliers. Deal with the noise. So signal processing, maybe they will always have a noise. For example, if you are a taxi driver, and then you are using the gyroscope and then the accelerometer to detect their motion, daily movement. Inside a car, they are taxi driver, so there are always some repeated actions of their movement. So this is not their physical action. So you need to remove this kind of vibration of the car, this kind of the noise. So we are calling noise. And honestly, noise are the repeated pattern. So it can be detected. Not easy, but it can be detected and then do it. And then, yeah, data formatting. So you need to make sure that your unit scale is correct. For example, whether you are using inch or using cm. So if you still remember, one of the accidents of we fire a rocket, right, is the wrong unit. So we always make the mistake. Human always make the mistake. One of the mistake is the data format unit. Second part, normalization, as I have mentioned. So, for example, your heart rate is maybe 80 something to 130 something, and then your pulse maybe 50 something to maybe almost 200, etc., etc. So they have different scale. And then they have different minimum rate and then a maximum scale. So when we want to do the machine learning or when we want to do this kind of calculation, we need to do the normalization so that we match all the things, all the dimension to 0 to 1 calculation. So the equation of the normalization is easy. It's the minimum minus maximum. Okay, so honestly, you find the minimum of your data, and then you find the maximum of your data. You minus so that you know the range, and then range becomes the base of your calculations. And then for each value inside, for example, data t equals to 1, you minus the minimum, and then over the range, and that is called normalization. So yeah, that is the normalization is easy to do. And then some of them, they are not only using the min-max scaling, they are using the z-score, z-score normalization. So they are using the standard deviation instead of the min-max calculation. So using a standard deviation, it helps to remove the extreme case, or we know that how far it try to different from the average, standard deviation, how far it move from the average. So yeah, both of them someone is doing, but honestly, min-max scaling, there are more and more situations, or I will say that most of the situation we use the min-max scaling because we don't want to miss out some extreme case. Extreme case in health monitor, maybe they are signal to handle. So we still do around this kind of settings. Min-max to the match the data to 0 to 1. So some of them maybe think that it's too small. So they will have the decimal scale like -1 to 1 or power them to 10. So make the calculation easier, because if you still remember, floating point in computer science is quite hard to handle decimal place, hard to calculate the floating number. So to speed up the whole processing, we will times, or we will have a better power to make it bigger. So we know the difference, and then it is make the calculation faster. Dimension reduction, especially when you are using the EEG or some brainwave. So you collect lots of the channel, and then you define a actions, and then observe the brainwave signaling. Most of the channel, they are useless. They are useless, especially inside the I would say the experiment setting. So you will collect different lots of the dimension. So you want to find out which dimension or which channel is the most important or wearable parts. Not most, they are wearable parts. Okay. So we use the dimension reduction, and then most likely you will use the PCA, principal component analysis, to do the feature selection to find out the meaningful dimensions, and of course reduce the complexity of the data. So what this PCA doing? So they compile a covariance matrix or correlation matrix. That means the dimension A and dimension B and your result are they correlate with each other by using the statistical analysis. So with this kind of doing, so you will have a compile matrix, and then you try to find out how the single value is different from the whole principal component. So with that, the top K or top K is number of dimension that is related to each other, and then find out the ratio. Finally, we will try to remove all the transform data into a reduced dimensional space. So we reduce the, for example, 128 to 36 or to even 2. So we try to reduce. Once our channel is reduced, if the data cannot find they have a I would say that co-relationship significant difference, that means the PCA is success. Okay. But don't worry, you need not to go through the deep inside the algorithm. Nowadays, PCA can be run in SPSS, the software, or you can just go to the website. Just like that, we have the dimension reduction, right? So we have some K-mean algorithm. You can find out the PCA algorithm in our math world or in other tools. So you can run it and then try to reduce the data before you do the production or before you do the experiment. Yeah, the last part, data segmentation. So as I have mentioned, so most likely data segmentation is related to the time interval. That means the time. For example, your heartbeat, so that is a signaling process, right? Signaling process. And then we need to, we are not going to observe each data point one by one. We just want to find out a patterns. And then what is the time interval of this pattern? So the t equals to 0 and t equals to t plus 1, t plus 2, t plus 3, t plus 4, etc. So there are time interval. We want to measure, we want to find out this kind of time interval. Sometimes we go to the activity patterns, and then even is an event trigger or even is a relay reference factor. So we want to find out the correct fixed time window to do the segmentation, to cut the signal for the signal processing. Because if you are just doing all the things from the raw data from the signal processing, it spends lots of the time for the machine learning algorithm and the expert to identify the correct pattern. So usually we do the data segmentation to help them to remove the noise, filter the outliers, and also find out the necessary data cleansing, and then prepare all the things better, and then go to a segmentation so that we can identify the key biometric marker from the signaling. So that is our main objective. So the data segmentation can be based on different criteria. For example, easier one will be fixed window. So that means for each 5 seconds or for each 10 seconds, 1 minute, etc., we get a samples, and then do it. Some of them, they will do the I would say that especially about the motion, so they will use the key point analysis. So they are the threshold-based segmentations. So PT student, so usually you have some, I would say that, I will say that in your Google Teachable machine, you are using the motion analysis. So you have some key points. You are not going to identify the in-between action one by one. So for example, you are going to have the T-pose. So you only identify the T-pose. T-pose. So T-pose is one of the key posture you want to identify. So to reduce the in-between data that you need to do, and then reduce all the things you need to take care. Of course, if you are lazy, you can just pass all the things to the machine learning, and then machine learning can also do the segmentation, or I will say that clustering for you. So they will, within the data, find out the key feature of your signal, and then try to find out the repeated patterns of your signal, and then do it. Nowadays good, you can still do machine learning based segmentation for at least for the first level, and then let the expert or let the health professional to identify the remaining. Still possible, is good.